Good evening, everybody. My name is Jay Parsons, and it's my pleasure to welcome you to the webinar this evening titled Optimizing Reproductive Efficiency in Sheep Production with Strategic Nutritional Management. This webinar is being offered in cooperation with the American Sheep Industry Association and the Rebuild the Sheep Inventory Committee, which is part of the ASI's Let's Grow initiative, and they've come to be known as the Let's Grow Committee. So we would like to thank them for their funding support and encourage each of you to visit the American Sheep Industry website to learn more about the American Sheep Industry, the association itself, and the various resources they have available for you, including the resources they have available on the Grow Our Flock website. And you can reach that from their main page by going to Issues and Programs and selecting the link that says the Rebuild Program. That ASI website URL is www.sheepusa.org. This program is being recorded and will be available for later viewing. A link will be placed on that ASI Let's Grow website, along with a email that will be sent out to each of you in the next 48 hours that will have a direct link to the recording and also to the PowerPoint slides that Richard uses in this evening's presentation. We're slated for about a 50-minute presentation and about 20 minutes of questions at the end, and we'll stick with that this evening as best that we can. You can type questions in as we go by using the dialog box in the lower right-hand corner of your control panel. I'll be monitoring those throughout the session, but we'll handle all of those during the Q&A session at the end. So with that, it's my pleasure to go ahead and introduce Richard Earhart, Sheep and Goat Extension Specialist at Michigan State University. Dr. Earhart is widely recognized as a leading expert in sheep reproductive efficiency. So this evening's presentation is being done by somebody who knows the trade, and I appreciate Dr. Earhart taking the time to put together the presentation and join us this evening to present it and answer the questions afterwards. So with that, I'll turn it over to Dr. Earhart.
Hi, Jay. Thank you very much for the nice invitation, and I'm pleased to have this opportunity. And again, sorry for those technical difficulties. It's really frustrating for everybody, but I'm glad that you've stuck with me. And yeah, I'm really pleased to have this opportunity to talk about improving production efficiency with strategic nutritional management. And just to give you an overview, kind of a roadmap of what I'd like to talk about tonight, first of all, I'd like to start off by explaining why reproductive efficiency is really an untapped opportunity in sheep production. I'm going to break it down into three main areas. That is the interaction between nutrition and ovulation rate and out-of-season breeding success. And then I'm going to end with a little more information focusing on ewe lamb development programs. So the neat thing about sheep production, which is often overlooked and sometimes not celebrated, is that sheep are a very efficient animal in terms of meat production, especially compared to other ruminants. They certainly have a higher reproductive efficiency than cattle. In fact, there are some programs in place, even in North America, that have as many as 4 lambs per ewe per year that they're able to produce successfully. And a ewe can produce close to 2 times her weight in marketable lambs per year. And that's pretty phenomenal when you think about it. And cattle are always going to be less than 1. And this is owed to the fact that sheep can have more than 1 lamb and they have a shorter reproductive cycle. So this efficiency really is explained by greater reproductive efficiency. And this is both prolificacy and birth interval. So really, why shouldn't we focus on maximizing this in a sustainable way? Okay, so there are 2 target areas to think about in terms of maximizing reproductive efficiency. There would be genetics and nutrition. The topic of tonight's presentation is going to be focused on nutrition by means of introduction. So here's just a broad overview of the nutritional management of reproduction in breeding age sheep. Okay, if you think about it, it's really a program. Each of these we can focus on as parts of this program, but you really need to think about this programmatically as 4 steps. They're all interconnected. Although I'm going to focus on pre-breeding ovulation rate, All these other factors, early pregnancy, mid-pregnancy, and late pregnancy, are all important parts of the program that have to be supported to have success in optimizing reproductive efficiency. So let's focus on pre-breeding and flushing. Flushing is just a term, again, for this enhancing the nutritional paradigm, the program of sheep, right during that time prior to ovulation. So the concept here is that the sheep brain, which is really what controls a lot of reproduction, ultimately at least, it's going to respond to signals from the animal's body that indicate that she's well fed, and thereby they increase the ovulation rate. There's signals from the brain that go to the ovary and tell the ovary to essentially regulate its ovulation capacity. So this will be the number of viable eggs produced, and this is mediated through signals in the brain. As I said, here's a molecule from the pituitary gland which is connected to the brain called LH, and you can see in well-fed animals it's much more pulsatile, it's secretion, but these are individual animals shown here, but in animals that are fasted, that shuts right down. And this is in rams actually, or castrated rams, but this holds true for intact males and intact females. It doesn't matter. Nutrition plays a large role in determining how the brain perceives energy. And this ultimately goes to the ovary and produces more viable eggs. So the greater this pulsatility and frequency, more intense signal, the greater the ovulation event, the more eggs that are shed during a single estrus cycle. So understand in considering this management situation that both short and long-term nutrition play a role in determining this ovulation rate. So I mean by long-term is, I mean the fatness of the animal. Fatness just doesn't happen in a day, it takes time, so it's a long-term energy signal. But then also just their current feeding, what they're eating right at that time, and their energy status at that moment, right during that estrus event, also determines the ovulation rate. So if you increase nutrition, and this is, when I say nutrition, I'm talking mostly about energy. For as little as 4 to 5 days, you can improve ovulation rate, particularly in animals that are underfed. So you take some underfed sheep, feed them real well for 4 to 5 days, you'll see a boost in ovulation rate. So it's that sensitive. So using positive energy balance, that's just a fancy term for saying that they're ewes that are actively gaining weight. So you can think about it that way. They're going to ovulate at a higher rate. So that's pretty much a well-known concept. Okay. However, recognize that fat ewes that already are up to their target body condition or even above, they're not going to respond as much. They may already be ovulating at their optimal rate. Okay. So what kind of responses should you expect if you do this kind of program? Well, increases up to 25% are actually typical. And I see this in the field quite often. I work with a lot of farms, and there's farms I work with that really have basically the same genetics. One system might feed their animals more energy, the other one might feed them less for different reasons, and you can see increases in lambing rate. In one flock might be 165, the other flock might be in the 210, 220 range. Exact same rams or basic rams they use, just fed very differently. And in fact, there's some studies that have shown increases up to close to 60% in very thin sheep. So thin sheep are very responsive. There's a colleague I used to know in actually in South Australia, who did some work to show this, and it was pretty profound. So recognize also, though, that this flushing response is going to be lost if these ewes lose weight or go into negative energy balance. So you don't want to let that happen. You know, you give them this energy boost, they gain this weight, but we want to make sure they don't lose the weight. So once they're bred, we can't let them slide backwards. Otherwise, they're going to lose these embryos that they gained. So right along, again, part of this program with flushing should extend into early pregnancy You want to make sure that they're at maintenance nutrition. Now maintenance again is that state where they neither gain or lose weight. So you want to make sure that they don't lose weight or maybe gain just a bit more during early pregnancy. Or again, you'll lose this benefit. Okay, so nutritional targets. What you want is a 20% increase in energy intake over maintenance for at least 2 to 4 weeks, okay? That's kind of your typical flushing program. It could be a little higher, but I think, you know, approximately 20% increase over maintenance is a good target. Maybe a better way, though, to monitor it would be in weight gain changes or in body condition scores. That's probably easier. So, you know, sometimes it's hard to regulate energy intake, precisely and know the requirements, but you can just look at the animal's condition score, and you should see them gain about half a condition score unit. And condition score unit is going to, how much weight that is depends on the size of the sheep a bit, but it's going to be sort of 6, 7, 8 pounds depending on the size of the sheep. So you should see them gain that much weight over this 2 to 4 week period. So again, the key is to put this U in positive weight gain. So you can increase or decrease the length of this program based on her condition score. So if you have super thin sheep, you might extend this longer. If the sheep are in pretty good shape already, you might just do 2 weeks. So this can be done in a variety of ways. There's different sheep production systems that are optimized for different conditions and different resource bases. So this could be done with the grazing systems, just with correct stocking rates, and by making sure that we have high forage quality in terms of how we manage the animals on a grazing program. It can be done quite precisely in a feeding program with energy supplement, and this could be a variety of energy supplements, which I'll describe just a bit more in a minute. So it's mostly about energy. Here's just a slide showing an example of a grazing-based flushing system where we've got some animals on some annual forages. This is actually was once a pasture, a different set of ewes. These are ewes on an accelerated program, gave birth on this pasture in May. Now these are those same ewes after they weaned their lambs in late August, back on the same pasture that was killed in late June, early July after all the ewes were finished lambing, allowed to grow brassica Sudan grass mixture, and these ewes just gobbled this up and gained a lot of weight. And it's a really good flushing program and a good sort of pasture improvement program as well. So that's just one system. There's other ones that are maybe more better for your particular program. I'll get that in a second. So yeah, I'll pick that up in just a minute. In a related way, I'm going to talk not just about flushing, but also how nutrition improves out-of-season breeding. Now, there's an interest in out-of-season breeding to try to even the lamb supply, but one of the critical things that's often overlooked is to make sure these animals are well fed. If these animals aren't well fed, they don't conceive in a predictable or even in a reasonable degree unless they're well fed. So the concept here is the sheep brain responds to signals again, indicating the animal is well fed. We don't know what all those signals are. We can guess. It's not too important for this discussion, but recognize that's kind of the concept. And this will allow her to overcome that seasonal constraint on conception. Some breeds are more aseasonal than others, but even the sheep breeds that we consider fairly aseasonal still have some nutritional barrier typically. At least that's what the picture that is emerging says. So this concept also applies to rams. So if you improve male nutrition or ram nutrition in out of season, they're going to have much greater libido and fertility, as I'll show you in a minute. So again, this concept really only applies to sheep with the genetic capacity for out of season breeding. So, you know, you just can't take a very seasonal breeding sheep, feed them well, and expect to get them to breed out of season. It'll help, but it's not going to be as effective unless they have that, at least that capacity. Here's just a study that was done in Australia that looked at this concept, and this was done in rams, and it applies both equally well to ewes. And again, here what they measured here is this thing called LH pulsatility, which you can see here. Oops. And what they found is during the normal breeding season or the optimal breeding season, which in our case would be in, sort of October, November, you see that if they had both well-fed, as shown in solid line, or maintenance fed, which means animals that were fed just not to gain or lose weight, sheep of two breeds. In red we see the Suffolks, and in yellow we see Merino, which is a wool breed, of course. What we find is during the optimal season, both breeds respond very well to nutrition. They increase this pulsatility. They also measured things like scrotal circumference, all other indicators of fertility, and in every case, each of those readouts all showed this response to nutrition. So even during the optimal season, it's a good idea to get your rams on good plain nutrition so that they have this higher libido, higher testosterone, greater fertility, greater serving capacity. However, during the less optimal season, so in our case that would be spring, when they fed these Suffolk rams a bunch of feed, they simply got fat. They didn't increase their LH pulsatility at all. Their testicular size didn't increase, but those Merino sheep, which are aseasonal sheep, at least they have the genetic capacity for out-of-season breeding if they're well fed, they responded with its increase in pulsatility. So you can see there's a pretty big difference between the spring breeding versus the fall breeding, that these Merinos responded. And that's kind of what we see in a lot of our aseasonal white-faced sheep that we work with. We see they respond to nutrition and they increase their testicular size, and that's an important thing to keep in mind. Here's just some work that I did a while ago now. It was a field study, pretty simple study, where we looked at ewe fertility and lambing percentage during October in 2 commercial flocks. These were really derived from the same genetic base. In fact, the high fertility flock shown here is a flock that was purchased at a bunch of ewe lambs from the low fertility flock. And these animals were, these comparisons were carefully made to account for differences in ages, so they're the same age sheep, same sort of age structure in the flock. But you can see that during this October lambing period, fertility was only 30% in this low fertility group. This high fertility group was really good. It was almost like the normal breeding season. I mean, they had over 90% conception in the spring and lambing in the fall. So that's really excellent. Likewise, the lambing percentage on these low fertility flock was quite low, only 1.3. High fertility flock was over 200%, which is really good for the fall. This is without hormones. This is just natural mating. And so this kind of begs the question, what the heck is the difference between how these animals were managed in this high fertility flock versus the low fertility flock? You know, what accounts for this difference? After all, they're the exact same genetic base, the same rams and the same ewes, pretty much, from the same source flock. So here we have these low fertility and high fertility flock. We looked at body weight here and body condition score here. And you can see that they differed at the beginning of the breeding season. The high fertility flock, the animals were heavier and heavier body condition score too. Not a huge difference. Recognize again, these sheep just gave birth during February, so they're they just got done weaning their lambs. They're a little bit thin, so their body condition score is only at not quite a 2.5, even for the high fertility flock, but recognize that it's better than the low fertility flock. And the same thing holds for weight as well. At the end of the breeding season, shown here in the pink bars, you can see a pretty big difference. Both flocks gained weight, okay, but their incremental increase was greater in the high fertility flock. So these animals simply were better fed. You know, it's as simple as that. And there were significant differences in an interaction between flock and time, and same with body condition score. These animals improved to almost a condition score of 3.5 at the end of the breeding season. If you don't believe condition scores and think they're somewhat subjective, just take a look at the weights and they tell the same story. So there's a big change in plain nutrition. So just to summarize this, during fall breeding, the normal breeding season of sheep, the threshold to get animals bred is rather low. Like even skinny ewes will get bred. So we look at the underfed and well-fed flock. We think of maybe their body fatness or whatever that read is of energy status that makes them get bred. We don't know. Here's just a bunch of animals. In the well-fed group, they're well above the threshold. In the underfed group, they're within that threshold. However, during the spring breeding, that threshold goes up, meaning that you have to have these animals better fed so that they get bred. So in the underfed group, not many of these animals get bred because they're not over that threshold. So this is just kind of a conceptual idea here, just to show you at least what my thinking is regarding this issue. So what kind of responses should you expect? Well, I would say, unfortunately, they're not perfectly clear, and I'm just being as honest as I can because there really isn't good research in this area or extensive research. And that's something that we want to fill here and learn much more about. However, field evidence, field studies that myself and other people have done indicate that certain breeds do respond to improved nutrition very nicely. As I showed you in that field study, those better fed animals were more than double the conception rate and a lot better ovulation rate as well. But recognize again that this improved nutrition isn't going to make a big difference in breeds that are not able to really breed out of season at all. So real seasonal breeders, you're not going to get much impact. They're just going to get fat. So what kind of targets are we looking at? Well, if we look at males, remember they're half the picture, of course, in terms of getting animals bred. We want to increase their level of nutrition quite a bit. In that study I showed from Australia, I did a little calculation, and it was more than double maintenance. Those animals were fed very well. So I'd recommend at least 1.5 to 2 times maintenance. So you want to get these animals in good shape on this rising plane of nutrition. Now, if you're talking about accelerated systems for out-of-season breeding, the nutritional treatment should begin during late lactation, and you want it to be at least 2.2 times maintenance. That is for ewes raising twins during that late lactation period towards the end after peak lactation, day 30 to 60, that late lactation period that we see for meat sheep. And then after late lactation, for accelerated animals, you want to conduct a flushing program, at least 1.4 times maintenance. You want to make sure these animals are well fed. I'd say a little bit more than during the fall breeding season. And if you're doing annual fall production, which some people do, you want to make sure, again, this is about a 30-day flushing period. So you want these animals gaining a fair bit of weight. Here's just a picture of ewes grazing. The neat thing about grazing systems is during spring breeding, you've got this natural spring flush in most of the United States that occurs. So you can take advantage of cheap weight gains by just managing the grazing conditions so that they gain weight by changing the stocking rate, making sure that they're on vegetative grass. Here's just some ewes actively getting chased by 2 rams during the early May breeding period. Another way to do it is to improve their nutrition with a feeding system. Here's a precision TMR being fed to ewes at a large farm, and that's another simple way, or not necessarily simple, but it's simple enough to feed sheep this way. Maybe it takes a lot more infrastructure, but that's another way to do it, and you can be very precise in that kind of system. So in this kind of system where you're formulating diets in a controlled nutrition program indoors, you would want to consider feedstuffs, high energy feedstuffs. You don't need alfalfa necessarily forage. You just need high quality grass. You want to increase their energy. The protein's not so important. Nothing wrong with alfalfa forage. It's just if you can get some better deals on high quality grass hay, that'd be just fine. As long as it's high quality, or haylage. Corn silage is great feed stuff. Sorghum Sudan silage, different kinds of high energy silages work really well. Corn grain, high moisture corn, barley, what have you. The main focus here again is on energy. It doesn't have to be real expensive forage because we're not feeding lactating dairy cows. Remember, we're just trying to get these ewes increasing their energy status. We can reserve these high protein feeds, which are typically more expensive for lactation in sheep, and maybe these moderate protein feeds for late pregnancy. This is a time where protein is not so important, but energy really is. Flushing diets Also make good diets for replacement ewe lambs, which I'll talk about next. The target protein for these types of diets might be around 11%. I mean, it's not going to hurt if you feed more, but it might be sort of a waste of money. So you don't really have to buy expensive protein supplements to have an efficient flushing program. Okay, so the next chapter I wanted to talk about, and I've covered flushing in sheep, and now I talked about flushing and improving nutrition during the out of season. I'm going to talk about ewe lamb development next because that is an important nutritional program as well. And so as an overview, I'm going to just ask the question, hey, is this a good idea or not to breed ewe lambs? What I mean by ewe lambs, these are lambs under a year of age. And you know, is this a reasonable thing? Because it's somewhat a debatable point in some producers' minds, and for various reasons. I'm going to talk about some of the factors that determine when these animals reach puberty. Then finally, talk about some practical guidelines for replacement females, how to develop them, and what sort of development program to follow. So looking at the question of whether it's reasonable and worthwhile to breed ewe lambs, let's consider this study that was done, and there's been several other studies done at, I believe this would have been in Du Bois quite a long time ago now, published in the late 60s. What they looked at here is a number of breeds, Rambouillet, Targhee, and Columbia, which are all you know, really well adapted to the Western conditions. And what they looked at is whether the animals conceived and bred their first winter and lambed at less than a year of age. And then they looked at the cumulative performance in terms of number of lambs born and number of lambs weaned over the next 5 years of life, okay? So they looked at those that bred as lambs, and then they took that out of this calculation. So this would be the lifetime cumulative performance of these different breeds, taking out their first lambing. So of course the ones that didn't breed, you know, would naturally have 0. So what you see here is that for the rest of their life they had a higher number of lambs born and naturally number of lambs weaned if they bred as lambs. Again, taking that first year of production out, and this held true for every single breed. And he looked at the average, it was considerably greater, and you saw a 9% greater lifetime pounds of lambs in those that are able to breed as ewe lambs. If you think about it, that's a pretty powerful thing for lifetime productivity. So if you think about it, the ability to breed as ewe lambs is probably a reasonable selection tool to find the most productive sheep for the rest of their life. Does this hold up for more productive or prolific breeds? I got to think so, and perhaps it's even more dramatic. I can't really say because I'm not sure we have the data to say that. But certainly in these kind of moderately productive breeds, it's definitely a phenomena. So how does this happen? I mean, why do ewes that conceive as lambs have greater lifetime productivity? I mean, these are kind of questions that make me curious. Just thought I'd present them. Some of the thoughts on this, some of the hypotheses might be that these ewes that lamb at less than a year of age or just slightly older, maybe that mothering experience, separated from their genetics, has a beneficial impact on mothering later in life. Maybe they're better moms, who knows. Maybe the genes that control this early puberty are linked to those that control ovulation rate, which I think seems like a reasonable hypothesis. And then perhaps the genes that control early puberty are linked to other things that are important in ewe productivity. For example, mothering ability, or the genetics of mothering ability, which is a genetically controlled response as well. Perhaps milk production, perhaps even embryo survival. There's a number of things that could be linked to these genes that control early puberty. We really don't know. What are some of the factors to consider? I mean, I talk to a lot of farmers, visit their farms, and some of them, you know, they have valid reasons for not breeding ewe lambs. And I thought I'd go through some of those considerations so you don't just dive headlong into this. First of all, do you have the feed inventory? Do you have the quality forages to allocate, to give to these growing or pregnant ewe lambs? Because they're going to need better nutrition. And what is the feed cost in terms of enhanced productivity? Okay, I'm going to do a quick back of the envelope calculation on feed costs. I find it's about 30% greater to develop ewes to 27 months of age if you had them lamb at 12 versus 24 months of age. So it's going to take about a third more feed if you have them lamb as lambs versus 2-year-olds. So that's a bigger input cost, of course. And how much greater productivity they have in that first lambing. I mean, those first ewe lambs, after all, often have a hard time getting over 1.2, 1.3. In a prolific breed, they might get 1.5, 1.6, but it's not a big response. So, you know, that makes it kind of a question, maybe perhaps a questionable return, if you think about it in that simple way. But on the other hand, I would say, ask the question, aren't these non-productive ewe lambs a dead asset? They're just sitting there in the back of your barn, wherever. There's overhead and maintenance costs associated with holding those assets, and you're not getting any return until they're quite old, okay? So that's something to consider. And then another question on the other side would be, what about the extra labor involved? Is there extra labor involved in lambing ewe lambs? And if there is extra labor, is it worth it, okay? And another important consideration is we're going to have non-fertile sheep, whether they lamb at females, whether they lamb as ewe lambs or whether they lamb as 2-year-olds. If they lamb as 2-year-olds for the first time, they're not going to be worth too much by the time you figure that out. You're going to have held them for a long time. But if you, but the salvage value for ewe lambs is very high, particularly if you do ultrasound and determine that they're not pregnant early. You can sell them as fat lambs, so you can get a lot more money for them. Finally, another consideration would be generation interval. If you're interested in a breeding program where you're seed stock producer, breeding ewe lambs is going to reduce this generation interval and increase your selection pressure. And so I'd say it's a must for seed stock producers, although I know a lot of them are not as interested in doing this. So here's just a picture quickly of doing some quick real-time scanning on ewes. One very popular program is to expose all these ewe lambs to rams and keep the ones that get conceive and sell the rest to market. So this can be done about 40 days after you take the rams out, so you can get these guys to market quickly and still get a really good price for them. So in summary, I'd say selection of ewes based on the ability of lambs is going to favor greater lifetime productivity. That's been shown multiple times in many studies. Recognize the salvage value of these open ewe lambs, those that are not pregnant, is very high with early pregnancy detection with the use of ultrasound. But also recognize that these pregnant ewe lambs are going to take some careful management for success. I'd recommend that they're managed as a separate group in terms of feeding, in terms of birth, and in terms of breeding and rearing. And again, don't get your hopes up too high. Don't expect high productivity out of these ewes conceiving at less than 10 months of age. They're going to pay for their feed, but not a lot more, okay? And I'd say, saying it kind of bluntly, I'd say it's kind of a no-brainer in accelerated production. So people are really trying to push the envelope a little bit, and also with seed stock producers focused on genetic gain and reproductive traits. So thinking about puberty, what are some of the factors that determine and regulate the onset of puberty? Well, thinking about it, we have basically 3 main factors to consider. That is season, because actually season, influences breeding in sheep, just like it influences when they reach puberty. Nutrition is an important consideration, and of course genetics. Some animals reach puberty faster or slower based on their genetic background. So puberty, again, looking at this LH pulsatility, what we find is right before they reach puberty, they get more frequent pulses in intensity and duration, and during that fertile period, we see this nice pulsatile response. This happens pretty much in all mammals. Here's a slide I made just to show you that there's a seasonal influence on onset of puberty. It's kind of a working model I put together. So we have these optimal photoperiods for breeding, and this here is from October to 1 year all the way to January a year later, okay? So the real optimal photoperiods in this calendar I'm showing, which is a year and about 4 or 5 months, or year and 4 months or so, is during this October to February period, and again, sort of August to December. So these lambs born in October, they're not really exposed to this optimal photo period for puberty. When they hit puberty, it often takes them until they're about 270 days of age till they really hit puberty. The ones born in February are going to be delayed relative to the ones born in May, so they might not reach puberty until they're at least 6 months of age, whereas those born in May are exposed to this optimal photo period or light for puberty. So those guys, just as they're getting to be sort of 4 months of age, they're in this really nice light situation that really helps them reach puberty much more quickly. So those May lambs have light on their side in terms of reaching puberty relative to the February lambs, and certainly relative to the ones born in the fall. And I can say this because I work with a lot of accelerated production flocks, and we see different conception rates for these groups if they're fed the same, and that they reach their optimal point at which they reach puberty varies quite a lot, even in the exact same genetics. Okay, so nutrition certainly has profound influence. Here I just show a study that I did a few years ago where we looked at Finn Dorset ewe lambs. They were born in May, and they were grown either fast or slow. So we grew them fast at about a little more than half a pound a day on a grain-based diet, or we fed them slow on a forage-based diet. The slow-grown lambs were fed about to gain about half the rate, a little bit more, approximately half the rate as the fast-grown lambs. This is a typical scenario you see out in the field. So we looked at the percent of animals reaching puberty by 7 months of age by taking a whole lot of blood samples, you know, starting like 4 or 5 months of age to determine when they reached estrus. And we found that the slow-grown lambs, only 31% of them reached puberty at 7 months of age, whereas those growing quickly all hit the mark, okay? And if you relate that to body fatness, it was kind of interesting. So all these animals, we determined very precisely their body fatness by doing chemical composition on the whole carcass. So these were carefully done body composition measures. And we looked at the body fatness of the animals, and what we found is that those of the slow-grown group that reached puberty, because some animals fatten quicker than others, we found that the ones that did attain puberty, remember there were about a third of them attained puberty, they happen to have a body fatness of about 28%, whereas those that didn't reach puberty were only 20%. Whereas those fast-growing lambs were chubbier, they were 33% body fat. So I would say, just based on this and this particular study, that the body fatness to reach puberty is around 28%. You know, maybe a little less, but somewhere in the mid-20s. So that's kind of a threshold that you could consider and think about. So is body weight really a good estimator of body fatness? So we'd like to know, like, you know, because body fatness is important, would body weight be a good readout? Now recognize that sheep vary in mature size, so if you got a big frame Suffolk sheep at 90 pounds, it's going to be very different than a, I guess, a small framed breed like a Chevy at 90 pounds. They're going to be much more mature relative and much more fat. So sheep also vary in the shape of their growth curve. Some mature earlier relative to others, even in terms of, even at the same mature size. And then sheep also vary in how they're fed. So animals that are fed fast or slow gain partition energy into fat differently, or they don't, they have the ability to become fat because they have extra calories to drop into fat. So body weight itself is really a poor predictor unless it's scaled to mature size. So I like to think about it in terms of mature size. So I look at percent of maternal mature size, the mature size of the mom or the or the average mature size of the moms of both the ram and the ewe as kind of a good indicator of body condition. So in terms of what determines body fatness, well, animals they become more fat over time, so it's age, it's diet, whether they're fed fast or slow, and that's also their stage of growth. So those are three main factors. Here's a study that I did a few years ago now where we looked at animals that were growing fast or slow and their body fatness, and these were relatively small lambs, but you can see those that were fed as much as they can eat on an all-milk diet, for example, to really control their nutrition, versus those fed a milk diet to grow more slowly at less than half that rate. If you looked at these animals at any given body endpoint, whether they were 17 pounds or 45 pounds or distances in between, that they were always more fat if they were fed well. And that's just a simple fact of growth. Also, considering body composition, we know that body composition is very much dependent on the percent of mature size. So if you have small mature size sheep at a given size, they're always going to be relatively more fat than those that are of large mature size. This is a solid line in terms of fatness here at a given carcass weight. The large mature size animals shown in solid lines are going to have less fat and more protein relative to the small mature size animals. So that's important to consider. The mature size is a very important consideration. And also understand that lambs at about 70% of their maternal mature size have approximately 25% body fat. And as I mentioned before, that might be a good sort of threshold for puberty. And that's also a pretty darn good threshold for marketing lambs. So you basically kind of want these lambs to be similar to the market lambs in terms of their size at breeding. It's about 70% of their maternal mature size. So here's just a quick example of animals, how they differ in their growth curve. I took a quick look at a whole bunch of lambs for the MSU Suffolk flock that are really selected for maximum post-weaning weight growth versus some lambs that are predominantly Ile-de-France breeding. And you can see that at any proportion of mature size versus time at age, these Suffolk lambs were relatively relatively smaller in terms of their mature size, but these lambs just keep right on growing and growing and growing. So they're slow maturing animals relative to this fast maturing Ile-de-France breed, which you can see is already curving over and starting to slow its growth at 200 days, where the Suffolk lambs are trucking along pretty good. So to consider with that is that these animals with these early growth patterns may also achieve puberty earlier because they're partitioning more into fat. Okay, genetics are important. I'm not going to talk about this much today, but recognize that these breed categories, with some of the example breeds here, they vary a lot in their age at puberty. So these very prolific short-tailed breeds, for example, the Finn, Romanoff, these Northern European breeds, the Caribbean hare breeds, or West African hare breeds more appropriately, are also relatively early maturing. British down breeds are kind of intermediate. The Mediterranean fine wool breeds, Rambouillet and Merino, are later maturing. These hill breeds are even later, and these long wool breeds are pretty late maturing. But also recognize that crossbreeding or heterosis also influence puberty. So these crossbred lambs are going to reach puberty earlier than their parent breeds. So for example, if you take a Dorset and you cross it with a Finn sheep, you're actually going to have a sheep that is probably closer to Finn in terms of its age at puberty than Dorset, because you get this bonus in terms of hybrid vigor that favors earlier puberty. So heterosis has an important impact on puberty as well. Okay, so some of the guidelines I would suggest for developing ewes would be season of birth, genetics, and rate of growth are key variables. Ewe lambs during late spring have the least seasonal barrier to reach puberty and reach puberty the fastest if everything else is the same. Now, if you establish a threshold percent of mature maternal body weight, it's going to give you a good sound target to shoot for in getting these ewe lambs bred, but it might take some adjustments according to when the lambs were born and their genetic background. So I'm going to go through some examples as we wrap this up. Here's just, I would recommend as a base recommendation to breed at a target of about 70% of mature size to optimize this conception rate. And this would be for these February born non-prolific sheep. Okay, let's just say maybe a down breed, for example. So here's just an example of ewe weight, maternal average weight, and this ewe lamb target weight. So you got a bigger ewe, 108 or 200 pound ewe. You want a 140 pound lamb at breeding, where you got a more moderate size ewe, 160 pound ewe might only be 110, 112 pounds. But this will be adjusted. So here's some adjustment factors. Now this is just kind of a working model. I'm giving this as kind of a working guideline. I can't really say I've done research to validate all of this, but it would be just a reasonable starting point. So we look at their season of birth. If they're born later in the spring, they can be smaller. And if they're born even later in the spring, they can be 6% smaller yet. So I could breed these at 64% of mature size and these at 67. Now if they have genetics that are more favorable for early puberty, like Finn-Romanoff cross at 25%, I would subtract 3% more. And if they're Finn-Romanoff at 50%, I'd subtract another 6%. So they could be considerably smaller and get bred if they're bred, for example, late in the season, have a lot of this prolific breeding. So let's consider a scenario. Let's say we have 3/8% Finn ewe lambs with a maternal weight of 170 pounds. We're going to try to optimize this target breeding weight. Let's say their lambs are born in February. We wanted a lamb at 12 months of age. We take about 4.5% because it's 3/8. It's right between 1/4 and 1/2 for this Finn genetics. So it'd be about 65.5% of 170 pounds. Our target's going to be 111 pounds at breeding for these sheep. Let's say we have their contemporaries, lambs from the same flock, but they're born in May, a different period of birth, and we want them to lamb at 12 months of age. We'd adjust for the Finn genetics again, but we take another adjustment because they're in that more optimal photo period. So in this case, they're in this awesome, most optimal photo period for reaching puberty. So these guys would breed at 101 pounds. And in practice, this really does hold pretty true in the field, what we see. So further considerations would be, it might be wise actually to breed fall and these early season lambs a bit older so that they lamb at 14 to 16 months of age instead of 12 months. And the reason for that is there's kind of mounting evidence that we're seeing out in the field that ewe lambs that achieve a greater reproductive maturity before breeding, they're going to, because they exhibit more estrus cycles before conceiving, that these lambs are going to have less problems with things like early dilation syndrome. Early dilation syndrome is a syndrome that happens in ewe lambs that are kind of pushed to give for puberty early, and we see a high rate of these in early season lambs giving birth at 12 months of age. However, it largely disappears with the same sheep if they're delayed to lamb for the first time at 14 to 16 months of age. Okay. Again, if they're born late in the season, we don't see hardly any of this at 12 months of age, but if they're born early, we do. Lower percent mature size breeding thresholds can be used, but expect the conception rate to drop. So go ahead and breed those at 10% less than you think that I'm suggesting, but recognize that you're not going to have the same conception rate. And if that's okay, like you can still sell those lambs to market, and you really want to be more stringent in your selection, you know, don't push them as hard, but recognize you're going to be, you might be disappointed. So if you're trying to get 90% of them to conceive, you're not. You might get like 60, 70%. So what we find is a 10 to 15 pound weight difference, for example, it's going to decrease conception maybe as much as 30%, and many different scenarios I've seen in the field. Breeding ewe lambs as a separate mating group with higher ram coverage is important because they just don't show estrus quite as clearly. So I might put them at 3% for ewe lambs, so that'd be 1 ram to 33 ewes as compared to 2% maybe for mature ewes. So you want to increase the ram coverage a bit. And another thing, which might seem heretical to some, but lambing ewe lambs on pasture might seem like a silly idea, but if properly managed, and I've seen this a number of times, the lower human pressure may have improved maternal bonding. And so that can actually work pretty well if done really carefully. Finally, just a couple things to consider. Is there a penalty for growing ewe lambs too fast, other than it's kind of expensive, okay? Now, if we think about the world of dairy nutrition, which we know a whole lot more about than sheep nutrition, it's been considered for a long time that that heifers growing fast aren't going to have the same mammary development, and therefore they have lower milk production in the first lactation. So does that apply to sheep? Well, recent evidence indicates that this really isn't necessarily the case so much. It's mostly related to age. So the ones that are growing more slowly are just older, and that's why they have more mammary development and milk better. It's not related to body fatness. Just these fast-growing heifers are younger at mating than those growing more slowly. So it's mostly a fact of age. And in sheep, however, thinking about it, both age and season are likely important for mammary development. So, but milk production is often not a limiting factor because these ewe lambs generally have lower lambing rates, usually have enough milk for their lambs, so it's not such a big deal. But overly fat ewe lambs, on the other hand, making them really fat is going to be expensive, and they may be more prone to both rectal and vaginal prolapse. And that's just kind of a picture that we see in the field. So I'll summarize these ewe lamb development programs. So ewe lambs that are able to conceive as lambs are going to have a higher lifetime production. That's pretty well established. The ability to lamb during year one, it can be a practical selection tool. With any open ewe lambs, you can identify early with ultrasound. You can sell those lambs to market when they're still worth money, good amount of money. Also, body condition and fatness is going to be a big determinant of the onset of puberty, and the best way to use it, to consider it, is in terms of related to their body weight scaled to mature size. So using that percent mature size is a good predictor of when to breed ewe lambs. So I'd say for many breeds it's going to be in the 60 to 75% of mature size sort of scale, depending on their age and when they're born, or their breed and when they're born, excuse me. Prolific genetics are going to reach, like the Finn and Romanoff, high percentage, are going to reach puberty a lot earlier than other breeds. And again, the season of birth has a big impact on reproduction and onset of puberty. You need to consider that when developing ewe lamb rearing programs. Ewe lambs bred as lambs, just in terms of their management, should be separated during the breeding period, pregnancy and lactation for best outcome. Now, there's no rule that says you have to do that. I'm just saying that in the field what we see is that you get a difference, you get a better outcome when you keep them separate in terms of conception, pregnancy management, because they're not as competitive at the feed bunk, and lactation likewise. So thinking about kind of a real big overall summary on this talk, this is approaching close to 50 minutes here, is that planning nutrition, or how much their level of nutrition, has a big impact on ovulation rate, as I've talked about, conception, particularly out of season, whether they breed or not, and age of puberty. And management of feed resource availability to meet targets is going to differ. In grazing-based systems, we're going to be more worried about managing stocking rate, forage availability, and quality. Now, this is really a subject of another talk, but those would be the variables. And it's possible to alter their nutrition really nicely by good grazing management. Or in a feeding-based program, which we see a good number of these programs in modern sheep production as well in North America, management of the forage and concentrate inventory is going to be really important in optimizing reproductive efficiency. So anyhow, that's pretty much my discussion for this evening. And I know I went through some of it a bit quickly because it was getting a bit late here. But I'm glad to entertain a few questions if Jay is still online, I'm sure.
Yes.
And here's my contact information, likewise, if you'd like to follow up with any particular questions.
Okay, thank you, Richard, for both a very nice presentation, but also all the neat information that it contained in there. A lot of things to pay attention to. We do have some questions popping in, and I'm going to go through those fairly quickly as they come in. Once again, for our attendees, you can ask questions by typing them into the question box in the lower right-hand side of your viewing panel over there, your control panel. You can also ask questions directly with Richard if you'd like by raising your hand, and there should be a hand icon up in the upper left part of your control panel, and if you click that, I will see it and unmute your microphone and allow you to talk directly with Richard. So go ahead and type in your questions or raise your hand if you have questions and would like to ask him directly. We did have a question come in fairly early when you were talking about out of season sheep versus optimal, and they were asked specifically about Icelandics, if I can pronounce here. Are Icelandics optimal or out of season sheep?
You know, you kind of stumped me there, actually. I'm not aware of information on Icelandic sheep. You know, and it's sort of hard to predict because there are some sheep that are from the northern climes that are fairly aseasonal if they're carefully selected. Like, for example, the Finn and Romanoff, they're pretty far north. They're fairly aseasonal. But generally, sheep that come from more northern climes are fairly seasonal. So I'm going to guess that Icelandics are fairly seasonal breeders. But I would, you know, if anyone knows more than me, I haven't really looked at that carefully. So I'm sort of supposing they're pretty seasonal, though.
Okay, just a quick follow-up on that same question for traditional style Tunis. I haven't heard of that one. Tunis.
Yeah, Tunis are, I think they're American fat-tail sheep from Tunisia, I'm guessing, originally, and they've been, you know, kind of domesticated and improved in North America. Many fat-tail sheep are fairly aseasonal if they're well-fed. So my thinking is that they would be fairly aseasonal sheep and breed out of season pretty well. But, you know, again, that's a breed that we don't see big numbers of and really good information on, but I'd be inclined to predict that they might do pretty well.
Okay. We did have a listener type in that they do breed Icelandics and they would characterize them as very seasonal breeders. So
yeah, okay. That's what if you had me put my money on the line, I'd say they're pretty darn seasonal, just like many of the hill breeds in the UK. Because they're kind of selected under pretty extensive conditions. In Iceland, they don't have a lot of shed lambing, and so my guess is that they'd be pretty seasonal. So.
Okay, a question on weaning lambs off of ewe lambs. Okay, do you treat them as a separate group or turn them out with the mature ewes? Let's see, let me reread this here. I think she's talking about the ewe lambs. Yeah, after weaning lambs off of ewe lambs, do you treat them as a separate group or turn them out with mature ewes?
I think I understand. Yeah, so I described how I would say that is a pretty critical time for them to recover because, you know, they're going to be fairly thin and they need some recovery because they're still actively growing. So, you know, if you turn them out with mature ewes, you have to make sure for a grazing situation that you provided them plenty of grass so that they're not competing, because otherwise they'll tend to get out-competed. But in practice, I find that if I optimize the grazing conditions, allocate a lot of forage to them to get them to recover, that they aren't competing with the moms. At the feed bunks, they generally are competing more, so I might keep them separate. But in a grazing situation with high amounts of grass, you know, allocated to the sheep, they shouldn't be limiting, and they'd be okay. So it kind of depends on whether the feed is limited, either in terms of grazing management or at the feed bunk. You just want to make sure, because they're not as competitive as the older ewes, and they're really not going to catch up fully until their second lambing. By the time their second lambing comes, I would say they definitely can be incorporated in the main flock, but maybe during that recovery phase after the first lambing, if it's practical to keep them separate, it'd be a good idea.
Okay, very good. We got a couple of feed questions here. One of them kind of relevant because I see more people actually growing peas. And question is
Okay.
on pea screenings. Is this a useful feed for pushing ewe lambs or better for flushing ewes? Both? If so, why? But got any experience with pea screenings?
I don't have experience with that. I know that I'm assuming like field peas.
Hmm.
Um, One of the nice things about them is they don't take processing. So on a small farm, they're kind of a practical protein source. I don't think in particular, I think that they're actually reasonably high in protein. So there's nothing wrong with feeding them. I think they'd be probably a pretty good feed for finishing lambs or for lactating ewes. I think they do great on them. I'm not sure that they would be, you know, they might actually have more protein than is necessary. So maybe you want to put those with a group of sheep that need the protein a little bit more. But they'd certainly be a good feed for flushing ewes, and I'm sure they'd respond. But they do have both energy and protein, so it depends how much what your feed inventory is.
Okay, another feed question. This is with alfalfa. Does feeding
Mhm.
alfalfa or other legumes affect
Yeah.
ovulation rate and embryo survival before and after breeding?
Um, I would say that there is some evidence that really high protein diets and some ruminants maybe aren't optimal for embryo development. But I'd say, the verdict's kind of out in sheep. I would say that just the improved nutrition of feeding alfalfa or clover-based feeds is going to improve ovulation overall and not be a negative. There might be a point where real excess protein might be negative, but I haven't really seen good evidence to suggest that's the case in sheep. Another consideration that people get very concerned about are phytoestrogens, or like estrogen mimic compounds that you see in legumes. You see them both in clovers and in alfalfa, and there's some concern that those can interfere with conception, not necessarily ovulation rate, but just the ability to breed. And that's a very hard thing to predict in general, and I say this carefully. That's a bit overstated, that problem, but there are some specific strains of legumes that are more higher estrogen content, so there are good field reports that tell you that's a problem. But I say by and large, um, I know a lot of people breed their sheep on red clover and have no problems. So by and large, it's not as big of a problem as it's made out to be. But it is, kind of one of those I can never give a great definitive answer on.
Okay, very good. We did have a listener type in about the Tunis breed. They said they know several people that breed off season with Tunis, particularly in the southwest part of the U.S. So this,
Cool. Yeah.
yeah.
Yeah, that's good to know.
Okay,
That's what I would have guessed, but
yeah. We have a question on the blackface sheep. Is it more efficient to lamb in January, February, or April, May if you have blackface sheep? Any comments on that?
oh, um, efficient. I guess it depends what we mean by that.
Yeah.
But, if we think about efficiency, I'll tell you what, the sheep that lamb later in the season are certainly going to have more lambs, okay? So in terms of that kind of efficiency, yeah, they're going to have more lambs than if they're bred early. That's without a doubt. Um, they're also, you could think about labor. In terms of labor, generally lambing, and it depends where your climate is, but if you're lambing late in the season, it's always going to be warmer than in the middle of winter. I live in Michigan. Lambing in the middle of winter is a lot more work and a lot more labor at birth. Lambs, succumb to hypothermia, so all those things are much more of a problem. So I'd say there's much more efficient to lamb sheep late, but on the other hand, you have to consider your markets as well. So some people might argue that with some blackface sheep, that if their market is, for example, to sell lambs to the fair, well, lambing late in the season is just not going to cut it necessarily because the fair season might be, not at that time. But on the other hand, we find more and more in terms of commodity market of lamb where you're selling them purely for meat and not for other purposes, that those late-born lambs actually, the cost of production is lower on those lambs, and the markets are still pretty favorable even the next year, late fall and early winter. We don't see quite that seasonal crash of price that we used to see. So I'd say I put my money on the late season, certainly being more efficient, but I'd quickly add that we want to think about our market. So I don't want to, divorce that from the equation.
Okay, and we have a question on poor pasture. Are there any types of sheep that are hardier on poor pasture?
All right. Yep. That's a question we get fairly often. I guess it depends what we mean by hardy. If we consider a sheep that doesn't do much as being very hardy, I'd say, yeah, you could take some relatively unproductive sheep. They're going to do good on pasture in terms of their body condition, but they're not going to be working very hard, so you're not going to get much out of them. So there's sheep that are hardy, but generally they're less productive sheep. You take a very high productive sheep that has fast-growing lambs and she's milking like crazy, they're not going to be very hardy, but they're going to produce more. So yeah, there's certainly breeds that are hardy, and most of them are not very productive sheep. There are some exceptions where we find some sheep that maybe seem to hold their body condition a little bit better on pasture at the same, ovulation rate or lambing rate. So those are the kind of sheep that might be the kind of sheep you're looking for. So I'd say there are some breeds that are better at maybe forage conversion, but I think that also gets a little overstated too, but I'm sure there's genetic differences, but that would be a subject of another talk.
Okay. We do have one listener with his hand up, so I'm going to go to him next, and then I come back with a couple of questions, one on before breeding nutrition and one after. Dennis, are you out there? I'm going to go ahead and unmute your microphone. Dennis, are you there?
Yes, I am.
Okay, go ahead and ask your question.
I've been flushing my ewes with straight silage, not adding a whole lot of protein, or not at all actually. Should I be adding more protein to that silage-based ration?
This is corn silage?
For flushing.
You're talking about corn silage as your flushing diet?
Yes.
Okay. Yeah, I'd say 9%, 10% protein might be a little low. So, I would say, yeah, you see a benefit. I'd say you want them closer, a little bit higher than that, because corn silage is going to be fairly low protein feed, generally in the 10% or lower range. So you don't need much. So if you just maybe included, I don't know what you're in your feed inventory, but including some haylage would be awesome. Doesn't even have to be great haylage. It could just be like some decent grass hay, be 13-14% protein. You might just be just about perfect. Put like a third of that with corn silage, and that might be better. You might get a little bit better, I don't know, pattern of nutrients in the rumen and in the lower gut as well, just by changing some of the feed ingredients and just adding a little bit different forage. So, but corn silage is a great base, so I wouldn't, cut back too much on it.
Okay. Thank you, Dennis. Okay, we had a question on after you've weaned the lambs, how does one manage to dry up ewes and keep them in gaining condition for rebreeding in an accelerated lambing program?
It's a great question. It's an important consideration because, yeah, you're trying to dry these ewes up and not have them lose weight, and that's a tricky balance. In practice, what we do is when they get to be about 60 days of lactation, their milk production is going down, but what I would do is I would reduce their energy, like take the energy out of their diet largely for about 4 days, maybe give or take a day or two. That'll decrease their milk production, and about that time the lambs are eating a lot of creep feed, so the lambs will compensate and start adjusting the feed. So you're cutting back, and then once you turn off the faucet in terms of milk at weaning, the ewes don't have the same energy requirements anymore, and just kind of holding them on that same diet for maybe 3 or 4 more days. So this diet, this kind of lower energy diet, taking away the corn grain, for example, out of the diet, or maybe reducing the energy concentration by taking a little corn silage out, putting a little lower energy haylage in, whatever ways you have to accomplish that would be good for sort of a 4-day before, maybe 4-day after. Then you just gradually add that back in 3 or 4 days and bring them back up to energy. So these ewes are going to have pretty swollen udders, so we want to make sure that we bed them really well. And we find that if we do that, we don't see a huge increase in mastitis. In fact, I don't see a big difference in mastitis compared to those really intense feed and water restriction programs that you see. So, you know, it is an important balance. So we can just reduce energy for sort of 6-7 days, right? Wean them right in the middle of that, and then get them back on feed. And they're back on feed for 3 weeks then, approximately. They get bred. They've usually gained a whole lot of weight because you turned off that faucet for milk, and so all that extra nutrients they're consuming are going back on their back again.
Okay, we had a question asking if you had any grass species recommendation to add energy for flushing if you're limited to just grass-fed in terms of what you have available.
Well, species are part of it, but probably as important as any is how the grass is managed, of course. So if it's managed, grazed, well, it's, you know, what they call phase 2 growth, where it's really vegetative, actively growing. It's going to be much higher in energy, but there are differences in cool season grass a bit, or at least in pastures. Like this picture here, I have basically an orchard grass tall fescue pasture. This isn't really the most awesome energy pasture, and I've been experimenting, not really experimenting, it's nothing new, but been feeding them some ryegrass clover pastures, which do pretty well in our area, but they're not quite as tough as nails as this pasture shown in this picture. Those are better species, certainly. We get much higher gains in terms of lamb growth and much bigger increases in, you know, body weight gain in flushing ewes. So using those higher energy grasses that are just a little more succulent, like more of a ryegrass base, also helps. But some of it's grazing management and some of it's species, having a little more legume content.
Okay, very good. We got time for just 2 or 3 more questions, and I'll ask you a quick one since you brought up your picture here. We had a reader or a listener ask what breed of sheep we're looking at there.
Oh, all right. These are just Heinz 57 sheep. They're crossbred sheep. They're my own sheep, okay? I call them Earhart Specials. They're about a third Dorset, a third Ile-de-France, and about a third Finn. And there's some polypay in them, but not much.
Okay.
These are fall lambing ewes, about ready to give birth and pasture in the fall.
Okay, and we did have one question on wool yields in particular, but the listener said, wool yields. It looked like wool yields dropped with ewe lamb breeding. Did I see this correctly, and if so, is there any interest in further looking at this? I can't remember from your slide exactly, but comments on that.
I'll see if I can pull that up. Someone was paying close attention to the slides. That's awesome. Where was that? Somewhere earlier than this. Let me find it here. Oh, getting closer. All right. Oops, dang it. Here's the slide. Can you see that?
Yes, we can see that just fine.
Yep.
I didn't think there was a big difference.
You know, I'd say statistically, I can't say. I don't have the statistics in front of me. It looks like there's a small decline, perhaps, but the Targies we see. I see a small, basically no change in the Columbias, And on average, there's a small difference, but I don't know if it's statistically significant. I guess in a way that makes sense, that if they have more lambs, they're going to have less wool, because we know that these animals that are milking really hard and partitioning more nutrients into their milk are going to probably have less protein available for wool growth. It's not going to be, it's going to be a pretty subtle effect, and that's kind of what we see here. So I'd say, yeah, they produce a little less wool, but they're producing a lot more lambs. So if you look at the cost of producing, what is it, a quarter pound, half a pound less wool versus 36 pounds more lamb over their lifetime, you know, maybe that's something you want to consider, what the economics of that small decrease in wool, if it's real, versus this large increase in lamb, which is real.
Okay. And we did have another ration question. What about corn silage, dried distiller's grain with corn grain ration for flushing through the end of lactation? Will it work, and will you need to adjust mineral consumption in any way?
Will it work? That's a lot of corn.
Yeah.
What do you say, distillers?
Yeah,
Everything
corn
with
silage,
corn.
dried distiller's grain with corn grain
Yeah.
ration. Yeah.
Yeah, I mean, that I would steer away from a pure corn diet, I guess, if I could, because even though the energy content is going to be decent, just you're having all corn protein, and my reasoning would be that, you know, that's not going to be as efficient of a diet because there's not a good complement of amino acids for the rumen microflora. So I would kind of steer away from purely that diet. I would add some other kind of soy protein if I had it, you know, depending on the cost, or barley or some other kind of plant protein would be, I think, better. And as far as minerals go, well, there's a lot of phosphorus in what you were just describing if you were going to go that route. And boy, you know, that would be a major concern, is making sure we add some calcium to the diet to sort of balance that out. But for flushing use, it's not quite as important. I certainly think it could work, but it's just, it might be, I don't know, it just seems like not a very efficient diet in terms of just being so much corn-based products.
Okay, and we did have a question on red clover. What about red clover in use, and any effects on ovulation in particular?
Um, I can't really cite a study that looked at that, so I'm a little hesitant to give a quick reaction. Um, I know that red clover is awesome feed for grazing lambs. It's the lambs grow the fastest on red clover than any other feed, and I would think that by extrapolation that ewes would gain the most weight, really high amount of weight on red clover. In fact, we have a lot of red clover dominant pastures that we're producing right now as short-term perennial pastures. And so we'll be looking at some of those questions in the future, but I can't give you a quick answer.
Okay, and then the last question is on rumen capacity.
Okay.
Does rumen capacity matter for those sheep that do well on forages? I guess, how much variance is there in rumen capacity, and how much difference does it make?
Gut fill, you know, intake capacity. I'm sure that there are studies that will, there's people that will tell you that it's a big effect. Certainly gut fill is a limiting factor for intake in most pasture situations. However, generally the more significant impact on intake is just forage availability. So it isn't necessarily their gut being too small, it's the ability of that sheep to, just like a dairy cow, to get as big of a bite, every bite it takes, get the most forage possible. So if you increase the forage per bite by having a really dense stand, so they don't have to run all over Kansas trying to, you know, fill their gut, that makes the biggest difference. So I would think about it more that way, although I would say that there are animals that maybe do differ in their gastrointestinal capacity, but I'm hesitant to make a big deal about it. Like these sheep right here you see in this picture do seem to be high volume sheep. Perhaps they have more capacity, but that's sort of anecdotal. I can't really prove that that makes a big difference. But certainly forage availability, having a very dense stand, and having a very fertile stand makes a big difference in terms of how much feed they can eat on pasture.
Okay, very good. Thank you, Richard, for a nice presentation and also for answering all those questions that came in. And thank you to all of our listeners for attending tonight and asking good questions. We really appreciate that. And of course, thank you to ASI and the Rebuild the Sheep Inventory Committee and the Let's Grow Initiative for providing funding for these webinars. This webinar is being recorded, and that recording will be posted. And all of you that registered for this webinar will receive a follow-up email with a link to that recording, along with a link to view Richard's slides if you so choose. We do have a couple of other webinars scheduled coming up later on this summer and early fall. On August 25th, Dr. Dave Notter of Virginia Tech University will be joining us to discuss developing and using breeding objectives. And on September 22nd, Dr. Bob Van Zon of Penn State University will be joining us to discuss the issue of supplementation. So keep those on your calendar, or be pretty much same time, same place, and we'll be sending out invites to those as those dates draw nearer. So once again, thank you, Richard, for a great job this evening, and thanks everybody for attending. This is Jay Parsons bidding everybody a good evening. Thank you.
Thank you.